guess we'll get started here. My name is Deel. I'm with NetApp and have been working with Rochelle as the co-chair of the twig that produces Swordfish. And anyway, I wanted to talk about open source today. Projects are available now. And then I want to mention some additional open source projects that are coming up very soon. And then talk about where to find information. You pretty much find that last bit on all of the slide sets. One thing, if you didn't get one already, make sure you pick up a raffle ticket. Anybody attending any of the Swordfish talks can pick up a ticket each, and it's worth doing it because you could win a Bose headset. Okay. The Scalable Storage Management Technical Work Group is where we developed the Swordfish specification, and that's been going for some time now. And one of the things that that group does is it also maintains several open source projects. Those projects can actually help accelerate the development of a Swordfish implementation because they give you some practical experience about how to do what, etc. And all of those projects are kept in open repositories and on GitHub. And the one that's of interest for this stuff is github.com/SNIA, of course. And the projects we have cooking so far, there's another one coming in immediately. There's an API emulator, something that behaves just like a Swordfish implementation. There's a basic web client. It's a way to talk to the emulator or any real implementation and you just get basic information from it. There is also a Swordfish Datadog sample dashboard integration. In other words, if you use Datadog to monitor things, this is something you could start with to do your own dashboard to watch what you care about in storage systems that are managed by Swordfish. Same thing for Power BI. If you use that for monitoring situations in your data center, then you could do the same sort of thing there. And the newer projects are coming. Rochelle mentioned them earlier today. There's a PowerShell toolkit, which Chris has been working on, and there's a Swordfish extension to Windows Admin Center. A fellow named Barks has been working on that. And the more open source projects are coming. There's one we know of for sure. There's GoFish from Sean up here. He's going to be talking about that later. And there are a couple of others that I've talked to people about that are of interest. And I want to go through these. I'll start with the emulator, and I'll spend more time on the emulator because that's usually of greater interest if you're actually trying to do an implementation. And I'll talk about why that's the case as we go through it. First off, what the API emulator does, it does pretty much what you'd think it does. An emulator, in the definitions I'm using here, is something that acts just like something else. Well, this is that. It's not a simulator. It's not trying to act exactly like the implementation of something else. It's trying to act like the other stuff. So what the Swordfish API Emulator does is it responds to create, read, update, and delete operations through REST. In other words, post, get, patch, and delete. And it works in conjunction with the Redfish interface emulator the same way that Swordfish is actually an extension, a seamless extension of Redfish. So what we did for the API emulator for Swordfish is we added code for all the Swordfish resources. So there's a link here for where to find it on GitHub. Again, you can just go to SNIA.com github.com/SNIA, and you can find it among the projects listed there. And you'll also, when you go to the project, you'll discover that it has installation, user, and developer documentation available. I tried to make it so you can pick it up and actually do something with it. I'm going to show you some stuff here where you can pick it up and do something with it without knowing much about it. When you just start it up, you get an output on your console that looks just like this. You know, it isn't precisely this because it can vary, but in its default configuration, you'll see something very much like this if you just install it and turn it on and run it. And if you installed it and turn it on, you see this. You can go to a browser on the same system, and you can enter localhost :5000 / service root. You do, same service root you would use for Redfish for anything. So just /redfish /v1, and in its default configuration, this is the service root you would get. And the things that's of greatest interest if you're doing Swordfish, these two things have been added to the service root: storage services and storage systems. So right there, you know you're dealing with Swordfish, not just Redfish. Mm-hmm.
Mike, can you move your mic up just a little bit when you're pointing up at this screen? You fade out, yeah.
Yeah, it's, I can do that. I realize you can turn it. Is that better?
I don't know, you're not talking like this yet.
Look, okay. Anyway, you can use an ordinary browser to look at the service root from not just the emulator. You can actually do that with any implementation as well. The reason I wanted to spend more time on the emulator is because as soon as you realize you've already got a read-only client, that's what a browser is, then you're most interested in, okay, how do I make this emulator thing behave the way I'd like? So I'll go into a little bit more on the emulator then. In other words, what's the environment you have to install it in? How do you do the install? And then some notes about if you're running it, you're going to run into this stuff. You might as well, hear about it first. Talk about how it works internally, at least at a large, the top level detail. And then how to add your own stuff to it. Dynamic resources, and I'll explain what dynamic means in a bit. And there are final notes about the emulator itself. So the emulator really wants you to be using Python 3.6 or above. This is on Windows or on Linux. Virtual env, I use it. I really, really recommend you use it just to keep things straight so you don't kind of cross up your own dependencies. If you work on more than one project at a time, then virtual env is definitely recommended. And the Python packages you need to load, there are 10 listed here. Those are the only ones you need. Now, if you pip install each of those 10, you're going to discover later that if you do a pip freeze, you're going to discover a whole lot more got dragged in, because these actually drag in their friends. So, but those are the ones you need to install. And the actual installing of the emulator, the rest of it, on Windows, it's really easy. Sean's made it even easier on Linux. He wrote a script, which pretty much you run the script and go do what you meant to do. On Windows, it's still pretty easy. You create a folder or a directory for the emulator. You could use virtual env to do that, or a number of other things. And then you copy in all the stuff you find on GitHub. This is gross scale stuff, but it would work. All you do is you take exactly the Swordfish API emulator you get off GitHub, drop it in the folder. And then you go to the Redfish interface emulator. I'm doing this backward, it doesn't matter. Do the same thing. Now, when you drop in the Swordfish stuff, Windows is going to complain. It's going to go, you're going to overwrite some stuff. And you go, yeah, do it. And that's fine. And then at some point here, you will switch to a command window, which is what you need to install the necessary Python packages. And again, that's these 10. And you just do pip install on each of those. And when you've done all that, you just say run, you just say Python emulator.py in the command window, and you're back with your friend here, which this means you did the install correctly. Again, I want to emphasize this is the default configuration. In other words, if you bring it up and you don't do anything else, you just do the Python emulator.py, this is what you'll be seeing, something very much like this. you see me kind of dodging from saying this is exactly what you want, because it turns out that some of the packages and one of the main ones, Flask, shift over time. So the output varies, but it's always going to look a little bit like this. Okay. Things to know. First off, unless you always want to run the default configuration, I heavily recommend you go to the Redfish Interface Emulator and read the README. And it's trivial. You go to the project and you scroll down past the code, and that is the README. Just read that document. Probably the main things you need to know there are about how to use the emulator.py flags. It does support some flags. The ones that are of interest are, see, dashport, it defaults to 5,000. You'll probably never change that unless you're running more than one emulator on the same system. And something called debug, -debug, that's a flag that's passed straight to Flask. It makes the command window go crazy with information. And that's pretty much it for the flags. The file that's actually the most interesting and how to deal with it is emulator-config.json. That's a JSON file which sets some operational parameters for the emulator. And that has to do with whether you want to start up with an empty emulator. In other words, it's nice that it comes with some stuff prepackaged that you can play with instantly. But if you want to start with your own stuff or start with literally an empty emulator, well, that's the file you would go to say, you know, don't show me the eye candy, just give me my own stuff. There's a tool called Infragen, which allows you to generate a small environment through a different setup that's beyond what I was going to talk about here, but that's also controlled by the emulator-config.json file. Anyway, go read that file. It's well worth it, just to know what's going on. There's this file inside the repo. There's a directory API Emulator, and then there's this resource manager.py file. That's actually really important because that file says which resources are static, they're read-only, you can't change them, and which resources are dynamic. If they're dynamic, it means you can use CRUD operations to change them. In other words, they'll respond to and remember what you told them to be through REST commands. So hang on to that because there are static resources and dynamic resources in the emulator. The reason is really straightforward. When the folks that wrote the original Redfish Interface Emulator were doing their work, they didn't want to have to do everything at once. Yes, sir?
Yeah. So in terms of doing the update or delete operations, a few operations are just like this key, the value will change. But then some things like trying to emulate a firmware update itself in actual.
Are you asking about the difference between static and dynamic?
No. So if I have to do a firmware update kind of operation with this emulator, does it just emulate making that particular attribute change, or it also emulates there's a state machine behind it? So
It's not a simulator, it's an emulator.
Right.
You say change this into there's no.
You can take the bottom half off and plug your code in underneath it.
Right. I want to talk about that after a bit. Is that one of the things you can do? I've got a diagram later which makes it much more straightforward.
Oh, pictures. Okay.
Okay, back to the basics here. You need to know the things that are dynamic, static resources and dynamic resources. The reason that got built into the emulator was the folks that started with it didn't want to have to do everything at once before they could use the emulator. So they had this distinction there simply because some things they had mock-ups for, and as they went through the resources one by one and made them dynamic, they wanted to move it from the static column to the dynamic column. So that is there, and you can benefit from that too, because if you're doing something OEM, something where you need your own behaviors, that's something that you could use. Now, right now, all the Swordfish resources are dynamic. They've already made the trip from static to dynamic. In terms of the default configuration, there are 4 Redfish resources which are not dynamic yet. They're named here. Account service, registries, session service, and task service. Again, maintaining that difference between static and dynamic. Static resources are populated by JSON mockup files. In other words, if you work with Redfish or Swordfish, you almost immediately run into this notion of mockup files. So you can drop mockups into this directory called, I'm not going to read the whole thing anyway, the static directory. And those mockups become static objects if the resource manager.py file has been edited to say which pieces of those mockups are supposed to be static resources. So anything you drop in the static directory can be a static resource, but only if you go to play doctor with the resource manager. And this has nothing to do with dynamic resources. In other words, you can't put things there and expect them to show up in the dynamic side of things. Dynamic resources, you can populate those either by using CRUD operations for some things, not everything, or there is a tool in the Redfish interface emulator called Infragen. And the Infragen basically works by looking at a JSON file that describes what you want to have instantiated, and then it uses the ability of dynamic resources to create instances for you. So you can pre-populate what you find in the emulator. And that's actually how the Redfish resources are put in the emulator in the first place. Back on that screen where, I can't tell where it is, where that initial screen, it's talked about having 7 CPUs. Well, that's why there are 7. Somebody wrote a configuration file and they run Infragen at the beginning of, when you do startup on the emulator. And that's how those get there. Okay. Now the emulator does have one funny thing in there which is not really a Redfish or a Swordfish operation. And that's where you can send a post to a URI with a named object at the end and an empty body. If you send that to a collection, that's a signal to the emulator to go talk to the thing that would know what to do with that collection, and it instantiates an object called, in that case, new thing. And the way it does that is that dynamic objects in the emulator have what are called template files. And a template file is a copy of a new object where when the new object needs to be created, the emulator pulls in a copy, and then it's got certain ways that it will replace certain fields in that new copy. And then it puts that out there as a dynamic object you can work with from that point on. So, but again, I've tried to carefully label it. This is an emulator-only function. It's a trick. And again, the trick is there because in the early days, they didn't have a different way to tell the emulator, I need a new object here. So what they planned to do was to simply be able to create a new thing and then use patch operations to go customize it the way you really want it. That's still there. Works for Swordfish as well as Redfish. Okay, this is the diagram I promised. Talk a little bit, high level, about how the emulator works. You can go crawl through the code like I did, or you can get a handle on it quick right now. First off, it leverages Flask and Flask RESTful to handle REST operations. That's a well-known and stable web server thing that you'll find out there. So when emulator.py starts up, it does some housekeeping, which includes waking up Flask and Flask RESTful and says, here comes the stuff. And then it wakes up Resource Manager. Remember, this is the thing that knows between static and dynamic. Okay? That's also where the service root lives. That's in that file, literally. Down toward the bottom, you'll find the service root. And it knows exactly where to go to get what. So that means it knows which things are static and which things are dynamic. In the case of the static resources, as long as Resource Manager knows it's supposed to be there as a static resource, it will race off with a loader, grab all that stuff, and put it into a dictionary kept here. So when, and then the Resource Manager will register the APIs associated with those static resources. So anytime Flask RESTful rather gets a request, say a GET, for something that is static, then it actually talks directly to the Resource Manager about that. And the Resource Manager goes and visits this dictionary and hands back a copy. It's read-only, right? Now, in the case of dynamic resources, the Resource Manager kicks off each of these things to initialize what they need to do to respond directly to Flask RESTful requests. Dynamic objects actually have two pieces. One piece, this square here, is what I call an API file. Well, it's what it's called an API file. That's because they're all underscore API. And the other piece are these templates. Remember how I said that it creates a new dynamic object? Well, if one of the API files detects a post with an empty body going to its collection, it makes a decision, do I do that or do I not do that? If it does that, then it will make a copy of the template, fill in the fields as it's supposed to, and then return that object to through Flask RESTful if you do a GET on it. Last thing to point out here is that all these Swordfish objects are dynamic. I'm only showing one here and in blue, but they're all the same. It's an API file and a template file. And the API files are of interest because that's where you define what happens to post, get, put, if you want it, patch, and delete. So this is what Rochelle was talking about earlier. If you wanted, you could intercept things here and go get the information if it's a get, or go do something if it's a post or a put, or whatever. So if that's what you want to do, this is your friend. The API files, you don't really need those unless you want to support that emulator-only function. That's one of the things I want people to realize is that these are here for that early convenience that not everybody's going to need. So you could just ignore that part. If you create your own dynamic devices, you don't actually have to have the template unless you plan to do the trick. Okay, speaking of creating dynamic resources, how much of this have I already gone over?
The whole thing.
The whole thing. She's much faster than I am. Anyway, not quite.
You didn't do the sub-resources.
Yeah. If you want to create your own dynamic object API and template files, there are examples waiting for you in the directory where all the resources are kept. EG underscore resource underscore API dot PY is probably one that's most interesting for most things. Some resources are top level and sub level. In other words, if you go to, we'll pick one, chassis. Chassis points to other kinds of objects like thermal, etc., which are sub-resources. It'll be better if you started with the sub-resource underscore API file for things that are sub-source. Now, in the case of chassis, I picked on that because it's what I remembered right now, but that's already there. Don't worry about that one. Did I forget anything there? Right. The only other thing here really is that those API files handle collections as well as singletons. There are actually two sections. When I did a cleanup sweep going through the emulator, I put all the collection things second, and the top are the singleton behaviors. The collection behaviors are usually just get, unless it supports the put that's got tricked to create a new dynamic resource. This I have gone over. Oh yeah. Once you've created a new dynamic object, you have to go tell resource_manager.py that you did that, because you have to tell it how to register the URI with Flask RESTful. Last couple of bits about the emulator. There are some things that need to improve. Some of them are just haven't had time to get to it. One is, well, the obvious one is there are some things that are still static that should really be made dynamic, and that's fine. Another one is that a couple of Redfish defines URIs are just not supported yet. One of those is /redfish/odata. It's one of the arcane little ones that if you're getting started on Swordfish, don't worry about that right now. You'll run into that as a detail later. There's another one, /redfish/$metadata. Is there a V1 in that? I think there is. Doesn't matter. $metadata is another one that's not supported yet. It'd be easy to put it in. Nobody's done it yet. And last about the emulator, feedback is good. Please leave issues or comments on GitHub, and if you've got the time to help, then please do. Moving on, Swordfish Basic Web Client. The Basic Web Client is a little bit like debuggers people used to use many years ago. No breakpoints, but it's essentially a web client that can connect to multiple Redfish or Swordfish implementations or the emulator simultaneously. And it shows what's going on with selected things in a web frame. Now, I've got pictures here in a bit. And it provides some basic capabilities for updating properties as well as just finding out what's there in terms of objects and properties. You find it on GitHub, same thing. There's with installation user and developer docs. When you first log in, well, first off, how the web client works in terms of architectural arrangement is you fire this thing up, and it's actually a web server. Okay, and it's a middleman you've purposely created where you're going to use a browser to talk to it, and then it is going to talk to the emulator, Swordfish, or Redfish implementation, as many as you want. So when you first log in, only this left-hand panel is showing. You click on the Add button, which throws up the second panel here. You tell it where it is, give it a name. Turns out the name doesn't really matter. I name it things where I know what it means. And the user and password, I use admin for both of them because it doesn't really pay attention to those either. So this is a little bit of stuff that didn't ever get strengthened. The main thing here is that you will find it useful to give it a name, and you have to say an IP address and a port number. When you do that, you get the leftmost panel here. Ignore that for a moment. It puts up the thing you gave it a name for. This is why you want the name here, because if you have like 5 of them up here, you start wondering which one is which. So if you want to add another one, just click Add or whatever. If you get tired of seeing one, remove. If you click on the name of one of the things you're looking at, it throws up, guess what? That's the service root. That's exactly the same service route I showed you in a browser image earlier in the presentation. And again, you know you're looking at Swordfish implementations as Swordfish services, storage services, and storage systems.
And the swordfish icon at the top is right.
Well, we have our poor little flattened swordfish up there, yes. Okay, if you click on storage services, it throws up a panel and tells you what storage services there are. In this particular case, the emulator has by default 1 and 2. I had been playing with it before I took this image, so I put in something out here, all flash something. And you can already tell how the basic web emulator, web client works. As you click on what you're interested in, it'll throw up a panel to the right, and give you that information. If you run into the other side, it starts sliding all the panels to the left, and so you're going to slide over. If you want to get back fast, it turns out this little chain gets thrown with each panel that goes up. So if you want to go all the way back to storage services, you can click on here and it tosses all the panels to the right of that. So you can get back really quickly to whatever it is you're looking at. And I think that I just wanted to give a taste for what the basic web client does. There's one thing I didn't talk about is that on the properties, there's a pencil icon here. If you click on that, it will allow you to change any properties that the schema says you can change. In other words, if it's read-only, it's not going to let you do that. It will complain. Okay, we'll talk about the two sample integrations. And they're very similar, so I'm going to go over this one a little bit and then speed over the other one. Datadog, if you use that, there's a sample dashboard integration out there. Probably the main thing that it will be used for is that it's a starting point. If you work with Datadog, then all you need is something like this, and it speeds up everything you're going to do because, you know, how do I do this or that has pretty much been addressed. Anything you introduce, those are your problems. You can solve those. But the whole point of having a sample integration was to speed somebody along for, you know, they just want to take a look at the basics or they want to grow their own, or customize their own. Documentation is there as well. And this is my, it turns out the colors used for the sample dashboard are the kind that don't show up well in presentations, I'm sorry. Anyway, this particular image was looking at the emulator, and none of the data in the emulator is changing by itself, so all the lines are flat. Not very interesting. But there we are. And let's see. Similarly for, touched the wrong thing. For the Power BI integration, it's really similar, not precisely the same because Power BI is not precisely the same at all. And in this case, it's talking about system capacity information and stuff you can set thresholds in Swordfish. Like, you know, if storage gets up to the number you set, it will have an event, you'll be told about it. And Power BI for this particular sample integration has two kinds of dashboards. One is the main dashboard, which is here, and what it's showing is various storage pools of how much is used and how much is remaining at the bottom. And up to the top right there, it says that it's watching the 4 Swordfish storage services, and those are all clickable. If you click storage services 1, then it will take you to a child dashboard. Child is my word, by the way. I don't know what they call it. Where it gives you more information about that particular storage service. So it's something that you could make progress was fairly quickly if you use Power BI. Okay, and there are more open source projects that can help you work with storage, Swordfish and storage in general. And I'm just going to put up these for now. Turns out I don't have to talk about these a whole lot because you're about to hear from the experts who are creating them. The first one is accelerating Windows integration. This is actually the name of the next talk on the agenda, and it's about using PowerShell with Swordfish. Chris Leonetti up here has a set of tools that allow you to do that easily now, and Barks, who was here, there he is. We'll be talking about using Windows Admin Center with Swordfish also. And these are important integrations. I want to hear some of this myself because it's new. And the talk after that is called Golang support for SNIA Swordfish, and that's Sean McGinnis up here, who will be talking about using Go with Swordfish and Redfish. Where to find more info? These are pretty straightforward. If you want more information about Swordfish, the link we tell everybody to remember is snia.org/swordfish. If you want more information about Redfish, we tell everybody dmtf.org/swordfish. Redfish, woo! And there's one other link to know about for Redfish, which is probably most useful if you are a developer, and that's the redfish.dmtf.org. That's the site we support for actual developers, and it's where you can get to a common repository for Redfish schema as well as Swordfish schema. It's all there. And what that also means is that SNIA and DMTF are working together even more closely than we used to make this all happen correctly. And one more that could help you someday is this Redfish and Swordfish public discussion forum. This is redfishforum.com. It turns out that swordfishforum.com would work too. We made sure we closed that loop. It sends you to a site where you can ask questions about almost any aspect of Redfish and Swordfish. And the thing you want to know about that is that I say you get answers from experts. You get answers from the people who wrote the specs. And if you bring up a problem they haven't thought about or don't have covered yet, they probably snarl at you and then say thank you. Because we can only get this right with additional input. The repos, pretty straightforward. It's github.com and SNIA in one case, DMTF in the other. You will find a wealth of open source tools on the DMTF site. I'm talking about Swordfish today, but in fact there are several projects here that I look at because they've either already done something I needed to do or they've done something like what I need to do. So, well worth looking at the DMTF open source site, and ours is growing. That's specific to Swordfish. And the way open source works is it will probably become less and less specific to Swordfish and more useful to the fish world in general, redfish as well as Swordfish. And yeah, that's right. This is my civic duty. We welcome anybody to contribute to the SNIA open source projects. The only little catch here is if you want to contribute, we do ask that you go to this link, snia.org/CLA, and agree to the contributor licensing agreement out there. And all the projects are covered by the BSD3 clause for SNIA. And other than that, I'd be happy to answer questions if you have any. Otherwise, that's what I had, other than pointing at the next presenters, because I really want to see what they all have to say too. So, yeah, believe it or not, Barks.
And then mention the workshop and the things.
I've been bad. I'm remiss. There is a Swordfish workshop happening, a short one during the break tomorrow. It's the break, what time, Tom? Okay.
Oh, it's 2 to 6 o'clock.
Well, it keeps running, but it moves. But the one that most people will be targeting is the one from, what, 5 to 7? Something like that, where there will be multiple setups with people showing stuff related to Swordfish. And last time I have to say it is that be sure you get a raffle card before you leave. There's a Bose headset that you could get, and each of our presentations you're in, you get another one, so you improve your chances. And if there are no questions, then I think I'm there.